Now let's talk about the more specialized case of a right triangle, which we will often have because like to work in the orthogonal world where the y-axis and the x-axis are defined in our systems. So if we're using x and y, we can draw a right triangle here. And so maybe we call this A and B and C. So these are our sides defined for our right triangle. And that one thing that makes it special is that this is 90 degrees. So all the same laws exist, cosine, law of sines, they are exactly the same. They just are simplified because we have this relationship, which makes it easier. So with right triangles, we're going to use SOHCAHTOA most often because this makes it just lots easier for us. So in this, C is equal to our hypotenuse because it's a right triangle, which is also known as H. So you can use or the sine or the cosine with any of the angles. You just have to make sure you use the opposite or the adjacent side when defining that. So let's talk about this angle here. We'll call it theta. How can we define theta? We can use, say, sine of theta. So the sine of theta is equal to the opposite over the hypotenuse. So the opposite of theta would be B, and then the hypotenuse is C. So sine of theta is equal to B over C. Or we can use cosine of theta is equal to the adjacent over the hypotenuse. So the angle or the side that's adjacent would be A. So we would have A over C. And then if we want to use TOA, that would be the tangent of theta is equal to the opposite, which is B, over the adjacent, which is A. So we can define and find our angles in this way. We can also do that for this angle here. We can use the same relationships. And so sometimes this is also useful. And it's always really important to always just think through opposite and adjacent and hypotenuse for your triangles, because you might be drawing these with relationship to different axes. So if we are doing the sine of phi, we're going to use the opposite, which is A, and the hypotenuse, which is C. Or if we use the cosine of phi, we will use the adjacent over C, and then the tangent of phi is equal to the opposite, which is A, over the adjacent, which is B. So you'll notice that these look different even though they're using sine and cosine. Our angles are not defined by the sine and the cosine. They're defined by the opposite, adjacent, and hypotenuse and the relationship of those.